Globalvia is a worldwide infrastructure, transport infrastructure concession management leader. We're specialized in highways and railways. We have a strong commitment with sustainability, innovation, and efficient asset management. What we say is that we want to make a better world and we want to change the places where we are. We are currently present in 7 countries all around the world, in Spain, in the States, in Portugal, Ireland, Costa Rica, Chile, Mexico. We have 25 concessions, mainly 18 highways and 7 railways, and we manage more than 1,400 kilometers. We are owned by 3 pension funds, LP Trust, PGGM, and USS, who seek the internationalization of our portfolio, investing in long-term infrastructure projects where we actually are enabled to have really close relationship with public administrations and local ecosystems, which is very important. We have recently, well, that actually happened, I think it was last year, created Openvia Mobility, which is Globalvia's innovation and technological platform, a vehicle where we develop venture building and also venture capital mobility projects, always in mobility. As I said, we're a mobility tech company with more than 10 years of experience in managing roads and transforming mobility through innovative solutions, let's say. We are present right now in 3 countries, in Spain, here in Madrid, where we have our Center of Excellence for machine learning and especially for computer vision. We're also present in Portugal, where we are developing our mobility platform. We aim to become what we say the Netflix of mobility, servicing road operators and urban operators in more than 3 continents all around the world. We like to call them happy customers, happy road operators, B2B. And we're also present in the US, where we obviously have in Globalvia different concessions, but where we've recently launched an app, which is Slora, where you can actually pay all your tolls in Virginia. So we also have happy B2C customers. In Openvia, we're very passionate about technology, and especially we're very passionate on how computer vision and artificial intelligence can help us automate operations in real-world scenarios. We understand the importance of gathering and turning image into information in order to take decisions and make decisions, to be more efficient, to obviously lower the cost in operation, which is something that it's very important for a road operator, but also to generate new business opportunities. We have an open innovation view. That's where we're collaborating with BigML, and we collaborate with different other partners because we believe that new opportunities come when you collaborate. In this sense, we've created, jointly with BigML and powered by BigML, what we call smart license plate recognition, which is a vehicle identification software through license plate recognition, obviously, using state-of-the-art image processing and analysis technologies. And it's specially designed for critical intelligent transportation systems, ITS, but we're also looking onto different security and surveillance scenarios. But let me tell you that SLPR, or smart license plate recognition, it's only the tip of the iceberg on how we intend to transform the way roads are operated. So we've created, or we are creating, a suite that we call Car AI, and this suite has different functionalities around artificial intelligence, and it's based basically in image. So we've developed, and we can say that we already have this kind of minimal viable product that we're already using in some of our concessions, smart license plate recognition, which is a SaaS, real-time processing, top-of-market KPIs, and easy to deploy license plate recognition. But we're also working on vehicle categorization. We've run different tests where we're able to categorize up to 9 different categories, also using the maker, brand, and different fingerprintings. We also do count, vehicle detection for counting, for multiple purposes. And we're also looking into something very important for road operators, which is incident detection, slow vehicle detection, wrong-way driving, intrusions, people, animals, many things that you can find in roads that you would never really could even guess. And also pavement detection, checking what the pavement status is and trying to be more proactive than reactive when maintenance needs to be done. Those two last functionalities that we're talking about are also being developed with other partners. As I said, for us, developing things jointly with partners like BigML or any other different partners has become something very, very critical. Regarding this solution, we not only want to transform with AI and image the way roads are operated, but we also understand that it's critical to lower traditional CapEx ITS renewals by reducing the need of heavy ITS hardware and replacing it with just really, really easy to use and cheap cameras that can be easily deployed. And also OPEX, I mean, having like a really, really low OPEX, reducing, we will see afterwards, manual things that we do in processes like manual validation after you classify or you identify a license plate. I mean, just making also OPEX very, very low and easy for road operators. And we're looking into vehicles. It's something, as you can see here, that is very, very important. But we're also looking into people detection. We've already deployed some area-specific congestion detection for our railways operations after pandemic. You know, we're not really out of the pandemic, but we're getting out of it. It's become very, very important to guarantee user safety. So we also understand that people use cases, and especially for railways, it's going to be very, very important for us. So smart license plate recognition, where we started, what was the challenge? So you probably know the typical OCRs. So OCRs is a technology that identifies characters from printed books, handwritten papers, or in this case, license plates. With this technology, businesses can rapidly transfer physical assets, you know, like plates, into digital systems and do all the data analysis that is needed. However, this OCR technology has always experienced some key challenges. Structuring the data involves more than just the OCR. OCR technology doesn't really work standalone. You always need to combine it with image rectification, verification, or what we call in our sector the human validation, you know, with all these associated costs. Also, colored backgrounds can be problematic, glare, blur. Webcams are also a big challenge for traditional OCRs. So actually, and also to add, currently OCR solutions don't offer the possibility of, first, having and measuring your own KPIs for success rate and false positives. Normally, you just need to trust these solutions that normally are packed as black boxes. And B, you can't manage the different thresholds for success rates and false positives in order to adjust to your business needs. So imagine if you are operating a concession where you can't really afford to have a false positive because that would have a reputational impact on your concession or whatever reason, you need to have a very, very, very low false positive. Or there's other concessions where you can actually afford that and your success rate doesn't need to be so high. So you need to be able as a business to manage and trickle that. And additionally, the OCR systems that are in the market don't enable the creation of business rules. We will later see how business rules are very, very important to make those models even more accurate, treating things like, as you can see, shadows and weather conditions, unusual cases, well, many, many, many things that would be problematic and that you can actually solve with business rules. So basically what we did, and then we will deep dive a bit more when my colleague Daniel goes and does the demo. But we followed a 3-steps approach. So first we gather a preliminary data sample, 3,000, which then also obviously grew to a bigger data set from both front and back images to compound what we call in road operations a transit. Then we went with detection. So using the front and back images, we firstly ran an object detection algorithm, in this case, detecting obviously the plates, not only detecting just one plate, but also second plates, and discriminated the one that we didn't need it. The object detection draws a bounding box the objects found and labels the box with the object's name. The model predicts where in the image each object is and what label should be applied to the object that we actually found. The model that we've been using here is TinyYOLO. Obviously, there's many models, many algorithms, sorry, that you can use, but together with BKML, we realized that actually what they said, or what we believed, that it was going to be the most efficient algorithm, because YOLO object detector is, well, one of the fastest deep learning based object detectors. Then we went with character recognition, recognizing the different characters. It's exactly the same mechanism. Instead of searching for plates, the process looks for the characters, and it also assigns a probability to each class. So an A is an A with a 99% of probability, for instance, or an O is an O or a 0 with 49% of probability. After that, we did, very importantly, the state classification, identify the plate, as you can see here, the regions, different regions of interest. We crop the plate and pass it to the state classification, deciding which state is. At the prediction time, we use detected features to make the final classifications, to make it more precise. It is also interesting to be noted that when we did the state classification, we trained, we actually use different fonts and train it with different states. I mean, this was one of the things that make it like really appropriate and really nailed it with it. And we obviously started with American, as you can see, American plates, because we believe this was where the coolest and the deepest challenge was. With probably European plates, this would be much easier, but we wanted to start with something really hard. And taking all these promising KPIs that we were having, we decided to develop a solution with the front end and a back end, a solution powered with the BKML backend that enables data scientists, and why not advanced business users, to train their own smart license plate recognition models. Easy to use, very easy, and very accurate. And of course, all the things that we didn't have in the different OCRs, being able to have it. Now we're going to see it with Daniel. I'm going to pass it on to Daniel, that he's going to show you a bit of the demo of what we've been doing. And the floor is yours, Daniel.
Okay, thank you very much, Ángela. Taking what just Ángela said about SLPR, SLPR is based on 3 different machine learning models that we train separately and we combine to get results. Plate detection is the very first one. Is a detection algorithm that is able to detect any amount of plates on an image. We normally use images with just one plate, but the model is capable of working with any amount of plates in the image with no problems. For every image, every plate image we get from this principal image, we then do the character recognition. It's very important in the case of the United States to label correctly for this model, so you can teach your model which characters should be considered in the plate detection and which ones shouldn't be included. That's particularly complicated in the United States, as long as plates are not standard and they have different labelings, different names on it, and that's why you have to make the model know which ones are the ones that should be considered and which one not. After that, we have a classification algorithm for the states. It's interesting that we didn't recognize characters for this one, so directly we can check the image itself, like classification, typical machine learning problem of cats and dogs. We do that with the different states of the United States. So it doesn't matter if you can see writing down Virginia or you see a picture for the state, the algorithm is able of detecting that state. The most important part, we put all the 3 models together and we apply business rules. As Ángela mentioned, we treat things not as independent images, but as a whole transit and you have front images, rear images, and you put all together, and you can apply different rules to maximize the accuracy of the models. In the particular case of we develop in Virginia, United States, we get an 88% of success rate with 0.1 false positive rate. Just to give you an idea, the benchmark on the market at that time was around 72 or 75%. So as you can see, was a huge increase in that success rate. A smart license plate recognition application is aimed not to work outside of their customer requirements, but to put your customer inside the model creation, so you can improve results and fit the final model to the actual business necessities of our customers. To summarize things, what we can do with the smart license plate recognition, we have six different stages to create the model and put that in production. As you can imagine, the first one is getting the import data from the source. So we are creating a platform, as we mentioned before, to gather all the information from our customers and put that for several uses. Then we can create the data sets, cleaning up all those images that shouldn't be used for training and choosing corner cases that should be included to maximize accuracy. The third stage is labeling. That is probably the most important part. The case of the United States has shown us the importance of working together with your customer, so they can really teach us. We are European, so we don't know how to recognize many of the plates. What are the rules behind all those plates? How you can use how you can take the characters, the right characters, to put that on the MB and getting the information from the administration for that place. So all that process required a big input from our customers. Then the fourth stage is probably the most important part, but also this is one, because we have a complete automatization of the model generation. So basically only configuring some parameters, you get the models on a few hours. Finally, before going production, you fine-tune your model with all the business rules that applies. Business rules has, okay, which is the right place I have to use in case they don't match, the front and rear plates don't match, or what I have to do if I don't know if this is a no or a zero. So many different rules that all are focused on increase the accuracy and the adaptation of the model to the actual business rules of our customers. Finally, we put that model in production and we measure the KPIs permanently, so you can have a very clear idea of what's happening with your model, how is the performance of the model, and if everything is within the range you think it should work. So now we are going to show a very quick walkthrough of the application, so you can see all I've just explained. First, we choose a data set of the ones we have created. As you can see, this data set is based not in just images, but these images are grouped in transit. So we can add as many images of the vehicle we have to increase the results. That's a pretty important part of the process. So once we have created the data set, you can use this data set both for the model training and the evaluation of the model. As you can see, it's very simple. And the evaluation is the part where you can fine-tune the results. This curve represents the success rate versus false positive rate. So you can actually see what happens when you move your threshold and how many false positives you will get if you put that threshold on a specific limit. Also, you can see a confusion matrix where you can find out which are those characters that are more problematic or need a little more training, so you can add corner cases or specific plates that contain that character. So again, you improve your model performance. Finally, this is how the production looks when you finally have your model. Right now our dashboard only shows three KPIs, but these ones are the most important. First one is the amount of images, the amount of transit you receive per hour. So you can see that it should have actually receiving data. The second one is the most important KPI in terms of performance, is the accuracy rate. So you can see that your accuracy is in the expected levels you wanted. And finally, you can see the response times of the server. So in case you have some problems with platform or anything like that, communications, you can check out what's happening. Okay, wrapping things up. What we get when developing SLPR? Basically, the most important part in any plate recognition model is the success rate. So we increase that using cutting-edge technology. But more over that, we get that results allowing the customer to not to have a black box where you don't know what will happen with your predictions. Your predictions will be as good as you need, so you can fine-tune the false positive rate, the success rate you want, adapting that for your business model. As long as you construct the model next to us, our customers understand the importance of the labeling process, how to teach the model, and we create a continuous improvement circle that we think is pretty important for this business. As you can see, it's a very intuitive and easy to use, user-friendly platform. So it's aimed to users that don't have a specific machine learning knowledge, and we think it's critical to adapt this for any kind of customers. And this is just, as Ángela mentioned before, the type of the iceberg. So we are developing many other services based on this philosophy for machine learning applied to mobility. Thank you.